All right, so we have the last few examples in this section. So we have tangent squared x minus tangent x equals 0. So if we have something like this, we have a GCF. So we pull out the tangent x. So we're going to pull out, oops, hang on. My screen keeps messing up here. So we're going to pull out the tangent x. So go ahead and do that. So you're going to have tangent of x on the outside, and then you're going to have tangent x minus 1 on the inside. Okay, so you set each piece equal to 0, so you have tangent of x equals 0, and you have tangent of x minus 1 equals 0. So you're finding when tangent is equal to 0, well, that's sine over cosine is equal to 0. And when tangent is equal to 1, well, that means sine divided by cosine is equal to 1. So if you have sine over cosine equals 0, it's a fraction that equals 0. So the only way a fraction can ever equal 0 is if the numerator is equal to 0. So you can think of multiplying that cosine of x over, it goes away. So you end up just getting sine of x equals 0. And that happens at 0 and pi. Okay? And then when you have sine of x over cosine of x equals 1, there's 2 locations on the unit circle where that happens. It's basically we're saying sine and cosine are the same value. So if you think about your points, where do you have the same x value and y value on your unit circle? So where's the first one? Pi over 4, right? Where's the second one? 5 pi over 4, is that what I said? Yeah, that's right, 5 pi over 4. So it's in the first quadrant, and then it's in the third quadrant, right? Because it's a negative negative. So our answers are going to be 0, pi, pi over 4, and 5 pi over 4. All right, so the ones that we haven't talked about, so I told you guys to skip E on your homework, was this one. So letter J says sine of 2x equals root 3 over 2. So you could try to use a double angle identity. So that's what Spencer did, because he remembered all this from summer pre-calc, and he said sine of 2x was the same as 2 sine of x cosine of x. But then he ran into a problem. So don't write this, but this is what he has. And it doesn't end up really helping because we don't have it set equal to 0. If it was equal to 0, maybe it would work, right? So that's not going to be the way to solve this. So you learned all those identities, and it's not useful here. Okay, so what we end up doing is what we call a W substitution, and we talked about this before. So we're going to say let W equal 2x. So what we're really solving is when sine of W equals root 3 over 2. Okay, but there's a trick on these problems. If you have 2x, you want to find all of the answers not from 0 to 2 pi, but you want to find from 0 to 4 pi. You want to double the interval. Because what happens is a 2x represents a horizontal compression by 1/2. So once you find all of the answers from 0 to 4 pi, you're going to take all of those answers and then you're going to divide them by 2. So your solutions will end up being from 0 to 2 pi. Does that kind of make sense? So if you have 2x, you're going to go from 0 to 4 pi. Okay, instead of 0 to 2 pi. You're going to double the interval. Okay, so we're going to find all of those values for W from 0 to 4 pi. So we're saying, when does the sine of W give us root 3 over 2? So the first two are easy. It's like, okay, it's going to be pi over 3 and 2 pi over 3. But then you also want to think about going around. So you're like, okay, if I'm at pi over 3 and I go around again, now I have another answer on 0 to 4 pi. Okay, so you're adding 2 pi to each of your solutions. So if you have pi over 3 and you add 2 pi to it, you have pi over 3 plus 6 pi over 3. Right, that's 2 pi, 6 pi over 3. So what do we get? For the second one, you would. But for the first one, pi over 3 plus 6 pi over 3, you get 7 pi over 3. And then the other one, when you add 6 pi over 3, you get 8 pi over 3. So it's like, well, why do we do that? Because 2x is equal to pi over 3, 2 pi over 3, and so on. I'll do dot, dot, dot. So if I want to get just plain x, I now divide my answers by 2. So if I divide each answer by 2, if I take pi over 3 and I divide by 2, what do I get? Pi over 3 divided by 2? Pi over 6, right? It's the same as multiplying by 1/2. If I take 2 pi over 3 and I divide by 2, we get 2 pi over 6, which is really pi over 3. If I take 7 pi over 3 divided by 2, I get 7 pi over 6. And if I take 8 pi over 3 divided by 2, I get 4 pi over 3. Those are your 4 answers. Okay, so it's kind of weird. So if you have 2x, like sine of 2x, cosine of 2x, or whatever, you want to double the interval. You want to go from 0 to 4 pi. What do you think you do if you have 3x? Triple it. You go from 0 to 6 pi, right? So you want to always adjust your interval. All right, so that's what these last two are. So we have a 3x1 and we have a 2x1. Okay, so if we have cosine of 3x, again, we're letting w equal 3x. So what we're really solving is cosine of w equals -1/2. So we're saying when is cosine of w equal to -1/2? It'd be in the second and the third quadrant. We would have w equals 2 pi over 3 and 4 pi over 3. But we want to go from 0 to 6 pi. Okay, so this is where it gets weird. You're just going to keep adding 2 pi to your solutions. So if I have 2 pi over 3 and I add 2 pi to it, right, 2 pi over 3 plus 6 pi over 3 gives me 8 pi over 3. If I take 4 pi over 3 and I add 6 pi over 3 to it, I get 10 pi over 3. And now you're going to do it again to those new answers that you just got. So you're going to say 8 pi over 3 plus another 2 pi. So it's going to be 14 pi over 3 and 16 pi over 3. See how annoying it gets to write these? Can you imagine if you had like 8x? Ugh, cosine of 8x. That would take forever. I won't do that. I'll make it 2 or 3. All right, so what we really have is, not 2x, 3x is equal to all of those numbers. So I'm going to say 2 pi over 3, and then I'm going to do comma, dot, 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 because I'm lazy. Now we need to solve for x. So we're dividing every single answer by 3. In other words, we're multiplying all of the numbers by 1/3. So I get x equals 2 pi over 3 times 1/3 is 2 pi over 9. Yep. And then 4 pi over 9, 8 pi over 9, 10 pi over 9, 14 pi over 9, and 16 pi over 9. And if you did it correctly, all of those answers should be within 0 to 2 pi. Okay, that's how you know that you did it correctly. Good? All right, so this is as hard as I get. So we have 4 cosine squared 2x minus 3 is equal to 0. So we're going to add the 3 over. You can put parentheses around the 2x if you want to. It doesn't matter. You can divide by 4. And you can take the square root of both sides. Remember, whenever you take a square root, write plus or minus. So we get cosine of 2x equals plus or minus the square root of 3 over 4. So it's going to be plus or minus the square root of 3. And then the square root of 4 is just 2. So square root of 3 over 2. So again, what you're doing is you're thinking of that 2x as w. And we're going on 0 to 4 pi. We're doubling the interval. So we're finding when cosine of w is equal to plus or minus the square root of 3 over 2. So there's 4 different locations. So the cosine is the x value on your unit circle, so we're going out really far in the x direction. All right, so we end up getting w is equal to pi over 6, 5 pi over 6, 7 pi over 6, and 11 pi over 6. But those are the answers from 0 to 2 pi. So you also need to continue one more rotation. So if you go around one more time, that next one would be pi over 6 plus 2 pi. So 2 pi is 12 pi over 6. So we're going to have 13 pi over 6. So we're continuing to add 12 pi over 6 to each one. So 12 plus 15 is 17 pi over 6. 12 plus 7 is 19 pi over 6. And 23 pi over 6. So that's all equal to 2x, right? So our answer then is we divide every single thing by 2. Okay, so we're going to have pi over 12 5 pi over 12, 7 pi over 12, 11 pi over 12, 13 pi over 12, 17 pi over 12, 19 pi over 12, and 23 pi over 12. And we know we're good because 23 pi over 12 is not quite to 2 pi. See how it's less than 2 pi? So we're good. Does that make sense? It's kind of strange. All right, so I'm sure you guys probably had questions on the homework, right? In particular, the last two, were they kind of tricky? I think they're a little tricky. So I'll do those last two for you guys as well. Let me grab it. So you guys try E right now while I'm finding the answers. Yeah. G? Oh yeah, G was a little tricky too. Yeah. All right. Just add a page here. All right, so there were 3 tricky problems. So G was a little bit tricky. So that was 3 tangent squared x minus 1 equals 0. And then I think I and J were a little bit tricky. So 4 cosine cubed x plus 2 cosine squared x minus 2 cosine of x minus 1 equals 0. And then J. Okay, so we'll go through each of those. So let's start with G. So for G, if you add the 1 over and divide by 3, you get tangent squared x equals 1/3. And when you take the square root, you write plus or minus, right? So we get tangent of x equals plus or minus the square root of 1/3. So if I take the square root of the top, I get 1. If I take the square root of the bottom, I get root 3. So many of you probably rationalized and multiplied by root 3 over root 3 and got that tangent was equal to plus or minus root 3 over 3. And then you might have gotten stuck. So what I always tell people when it comes to tangent, you know that it has to be one of 2 things. The only points on the unit circles that you know are the ones that are 1/2 comma root 3 over 2, or the ones that are root 3 over 2 comma 1/2, right? Ignoring the pluses or minuses and all of that. So let's think about it. If I have 1/2 comma root 3 over 2, when I find tangent, I'm going to do root 3 over 2 divided by 1/2. What does that give me when I simplify? It gives me root 3, right? Do you guys see that? So that's not what I want. I want 1 over root 3, or root 3 over 3, right? So that's not what I want. So you can cross that one out. So the only other form that I have is when you have root 3 over 2 comma 1/2. Well, when you do tangent, it's sine over cosine, right? So if you find it, the 2's reduce out, you get 1 over root 3. Is that what I want? Yeah, it's definitely what I want. So it could be plus or minus on both of them. It doesn't matter which one's positive, which one's negative. If both are positive, both are negative, whatever. Right? It's still going to be plus or minus 1 over root 3. Yes?
You could use the identity equals, right?
What identity?
The tangent squared x equals secant squared x minus.
Yeah, I guess you could like replace it with secant squared and so on. Did you do that? And then you got something with cosine, something that was more familiar. Yeah. Yep, you could do that. All right, so for this, we end up getting tangent of x equals plus or minus root 3 over 3, which we just realized means that we have sine over cosine, and we want our sines to be in the form of 1/2, and we want our cosines to be in the form of root 3 over 2. And we'll put plus or minus for each one. Make sense? So we want 4 points on our unit circle that are in that form. So the sine is some form of 1/2, either plus or minus, and the cosine is some kind of form of root 3 over 2. So those are the 4 locations. So for this, we get x equals pi over 6, 5 pi over 6, 7 pi over 6, and 11 pi over 6. Okay. So Spencer says he did it the same way. He just took tangent squared and he used the Pythagorean identity to replace it. So what did you replace it with?
Well, first I did tangent squared x equals 1 over 3, and then I put secant squared x minus 1 over 1. Yeah,
so you replace tangent squared with secant squared minus 1, right? So you could do that as well. And then you would just convert everything. Once you get like secant x equals 2, let's say. If you had secant of x equals 2, then you say, well, 1 over cosine equals 2 over 1 and take the reciprocal of both sides. All right, does that make sense? All right, so we have that for G. All right, I was a little bit tricky. There are 4 terms, so you need to split the middle. So when you split the middle, you pull out the common factor, which is 2 cosine of x squared. So you get 2 cosine of x plus 1. You know you want the same thing if you're going to split the middle, right? So if you're going to get 2 cosine of x plus 1, you need to pull out a negative 1. So now our new GCF is the 2 cosine of x plus 1. And we're left with 2 cosine squared x minus 1. And we set each piece equal to 0. So the first part's easy. You get negative 1/2 is equal to cosine of x. So that happens in the second and third quadrant. So x would be pi, or 2 pi over 3 and 4 pi over 3. And then the other one's a little bit trickier. So some of you might not have recognized that that is a unit circle value. You add the 1 and divide by 2. And then you take the square root, writing plus or minus. And if you have the square root of 1 over 2, it's going to be the square root of 1 over the square root of 2. So 1 over root 2, which, like I said, doesn't really look like a unit circle value, but it is. Because now you rationalize, you multiply by root 2 over root 2. So you get plus or minus root 2 over 2. So that happens in 4 places on the unit circle. So first quadrant, second, third, and fourth. So we get x equals pi over 4, 3 pi over 4, 5 pi over 4, and 7 pi over 4. So this is one that has 6 answers. Did anybody get that all the way? Yeah, good. Some of you are not claiming you're like this. Maybe. All right. So J. So J is a little bit harder. It's not exactly set up in a way that's familiar at first. But you might have remembered these types of things from the identity. So one thing that you can always do is you can try to get common denominators. So if you have cosine of x and 1 plus sine of x, that means you're going to multiply the first fraction by 1 plus sine of x on the top and the bottom, and you're going to multiply the second one by cosine of x. Okay, but the key when you're doing these is to not multiply out that denominator, because a lot of times things will reduce out. So just keep the denominator how it is. So leave the denominator as cosine of x times 1 plus sine of x. And then do multiply out the numerator. So if I have 1 plus sine of x times another 1 plus sine of x, I'm going to FOIL. So you have 1 plus sine of x is 2 sine of x plus sine squared. And then you have cosine of x times cosine of x. So we're just going to say plus, and we're going to put it in the same numerator, cosine squared. And it all is equal to 4. So do you see anything that you recognize? Yeah, it's sine squared plus cosine squared. That's equal to 1. We always look for that one, the Pythagorean identity. So we have 1 plus 2 sine of x plus 1 is 2 plus 2 sine of x. And a lot of you guys, as I was helping people, I saw you got to this point at least, but then you had no idea what to do because you had already multiplied out the denominator. So if you multiply out the denominator, you may not notice that you have a 1 plus sine of x in the numerator and the denominator. So see how you can pull out a 2 from the top? And you have 1 plus sine of x. That reduces with the 1 plus sine of x on the denominator. So you can cross those out. So you get 2 over cosine of x equals 4. You can take the reciprocal of both sides if you want. Like it would be cosine of x over 2 equals 1/4. You could do that. Or you can multiply the cosine of x over and then divide by 4. So you end up getting 1/2 equals cosine of x. So there are only 2 answers for this one. So cosine is equal to 1/2 here and here. So it's going to be pi over 3 and 5 pi over 3 are the 2 answers. And that's it. Anybody get that one all the way? Did you get it? Nope. You got it? Good. All right, good. All right, so that's all the help I'm going to give you. That was plenty on the homework.